Welcome and thank you for joining us today. I'll introduce myself first. Corey Vogel, lead engineer at Target. I've been part of the team for about 5 years. Prior to that, I spent the majority of my career doing systems design.
My name is Brandon Markgraf. I'm a lead engineer at Target, and I am focused specifically on helping onboard OCP at Target.
Cool. So today, I'll give you a little bit of background on Target. I know there's a couple of presentations going on, but we'll dig into that. Overview of our compute environments. Brandon will spend some time with the hardware automation and how we manage our distinct locations. We'll break that out into data center computing. We'll also spend some time on our edge computing, and then dig into, how did OCP become a good fit for Target? Going over some of our lessons learned and, futures and next steps. A little bit about Target. We have roughly 1,900 stores across the U.S. Of those, 44 locations we have distribution centers. And then we have 350,000 team members worldwide. Target's main, obviously, locations, North America, United States. However, we do have teams in India that we work every day with. Each week, we work with more than 30 million guests. And to make that experience good for every guest, technology plays a large role in the background of Target. I mentioned that we do have two data centers. Those are today both located in Minnesota. Our distribution centers are dispersed throughout the US. And then we have the 1,900 stores. And one thing that we can kind of, take from this is obviously our data centers are very large footprints, multi-megawatts. Distribution centers, we would kind of look at that as like an edge data center. It can fit tens to hundreds of nodes of compute. And then we also treat our stores almost like remote data centers also, where we can have tens of nodes of compute in each store.
So I'm going to cover just what we have in place today for our compute hardware automation. So overall, our automation is meant to be zero touch post physical install and cabling. Our automation has to be zero touch as much as possible based on the diversity of our compute across the United States. It allows us to manage and maintain thousands of compute nodes within Target. Security is the base in which we build off of for all aspects of our automation pipeline, and it is integrated across all touch points. So if we look at the diagram in front of us here, so from a discovery perspective, this is how systems are consumed automatically. After that's done, we go through a validation process where we scan our systems to ensure configuration and security. Once that's completed, these are staged and we classify the systems based on network, hardware, and location, and that it's ready for consumption, deployment, and usage. From a deployment perspective, it's based on criteria of our consumers of infrastructure that can consume and release physical infrastructure as needed. When we think about recycling could be a couple different things. It could be end of life for that particular piece of hardware, or it's something that a consumer no longer needs, and it can be released and put back into a deployment area where it can be consumed by another consumer for another project.
Cool, thanks, Brandon. Just to kind of keep building on that, automation makes Target function. Without it, we would be slower than, most large organizations. So with that, kind of talking about our data centers, right? So with the two data centers we have roughly 7,000 nodes in those data centers, many different vendor supplied solutions. We work with any of the enterprise vendors that you can think of. And we utilize the same automation that Brandon was talking about, in addition to some of the vendor supplied automation. Also, we rely on third parties to help us support on-site hardware in the data centers. So along with our own Target staff. With any type of large organization, we're going to run into important snowflakes. Ideas there are financial systems. Some of our data analytics platforms requires special hands-on that don't fit into our zero-touch automation. So we do still have some systems that get more attention than others. In addition to that, obviously Target's very concerned about security. So we do have sectioned off, SOX compliant, secure zones that are handled with everything in that zone. Nothing reaches out. So while we still do consume some of the automation there, there's additional manual steps. But as we move forward, we want to get to common platforms, common configurations, reduced configurations, and take advantage of the efficiencies of OCP, buying only what we need based on specifications that we could get from the OCP community. And we can also focus more on our storage offerings, open storage, open hardware management, moving from dedicated HPC devices to open HPC devices, and last but not least, rack and power, right? So power and cooling is a big step for that. And then ideally, with these specifications, we can go to multiple suppliers, get the same exact device. We're not getting pieces and components that are mix and match. We can give them the spec and they can put it together for us. So that's a big win for Target if you think about all the dispersed locations we have.
From an edge computing perspective, I'm going to give an overview of where we are today from a current perspective. So today, Target has over 1,900 stores across the continental US. Each store location has 3+ compute nodes per location, which enables us to run a cluster at each location. This equates to over 5,800 compute nodes that Target builds, configures, and maintains, leveraging CI/CD processes and a variety of open technologies. The cluster allows our application partners to run microservices at each location. This configuration also allows us to have a more stable compute environment for our stores and gives us the ability to be agile when rolling out updates. It has helped us to standardize uptime during maintenance and potential failures while reducing data loss. The sheer amount of compute spread across 1,900+ mini data centers is a challenge in regards to expansion and serviceability. When we think about the future, planning for compute, memory and storage usage and expansion for a certain number of years to meet the demands of technology is a challenge. With the OCP designs, we're looking to reduce service and expansion complexities, utilizing all front-facing cabling as much as possible and a toolless design. Utilizing Redfish for our automation to build and configure and apply updates is something that we're extensively researching and investing time in. The minimal compute design, i.e. less components, will help in regards to less updates and failures, but it also is going to increase our startup time as well. We're going to continue to improve upon our existing automation success by continuing to leverage CI/CD automation and tools and open technologies. And as always, we're going to continue to apply any type of OCP learnings from other compute environments.
So, as Brandon mentioned, and I mentioned about data centers, why is OCP a good fit for Target? Target evolves very fast. So the flexibility of OCP working with the ODMs and the suppliers to get systems on the floor faster is a huge win for us. Obviously, with the fast moving pace that we go, speed is key. Typically when we work with OCP vendors, we can get infrastructure quicker because it's going through less, I shouldn't say less of a support process, but a reduced, right? So it's a shorter time period to get something from design onto the floor. Then also control. Brandon mentioned this too, is when we think about control over our destiny, it's a build versus buy type mentality. Specifications allow us to consume from various suppliers and abstract our hardware from our consumers internally, IaaS layers and above. So we can control what's underneath and we can swap it in and out without any impact to our partners on the platforms. And then efficiency, right? So we look at economies of scale in how we can work with open technologies and automation to create an ecosystem others can consume too. So the benefits of a community help us out in that effort. Just a couple of things to add on, right? So I mentioned the economies of scale, so value, right? Once we start, getting more people on board in the OCP community, get people joining as members, getting out there and advertising their products. What we're going to start seeing is, increased requests for those types of systems. And then as we buy more of a similar configuration, we can see that going down as if you're selling the same thing over and over again, it should be cheaper to produce. However, that's not always the case. But one big thing also about OCP is the power. Reducing the number of components in a rack is huge. All the power supplies, anything that we don't need in the systems, really reduces what we're consuming and allows us to focus more on how much CPU and memory and storage can I get in a node versus how many power supplies do I need. And then along that same front, with a better airflow, zero bezel design, we can pass more air through with less fans, and we can start evaluating running at higher temperatures and reducing the strain on our cooling systems. It also allows us to look at different locations for compute equipment within our edge locations. And last but not least, the community partnerships is a big thing for Target. We've leaned on a lot of communities in many different areas. Typically in the past, it's on software. This is our move into hardware.
So what have we learned so far from this? So from our experience, Target has brought in hardware from 4 different OCP vendors. The compute was tested in 2 different compute labs. The team developed very low touch automation for BMC configuration and OS deployment. The team leveraged existing internal tools and automation processes to complete this. We successfully deployed a POC in our lab data center to host hypervisor clusters on our internal platform. When you think about supplier adoption, the ability to adopt the hardware and racking was very easy for our data centers. Our top of rack switches still require AC power to run where compute can run on the DC power bus bar. Some compute configurations are limited due to the wattage limits per node. We did struggle a little bit when it came to shipping and receiving of empty racks, and we found that they bend just as easily as any other metal component. From support processes perspective, we did encounter some communication difficulties when onboarding new vendors. We did find that BMC and BIOS firmware is not publicly available from the vendors, and it's something that we have to work directly with the vendors to actually receive. So that was something that was very difficult for us. When it came to documentation, documentation was there, but some of it was limited. Sometimes it was tough to find, and it may not have always been very thorough. When we think about Redfish, we selected Redfish over IPMI due to its security posture and availability for all. Overall, we do not control our own destiny when it comes to Redfish versions and updates. That lies in the hands of the individual vendors as firmware updates. Target is not able to update Redfish versions as we see fit, and we have to rely on vendor testing and releases. This can cause issues when it comes to timelines and waiting for those new versions and functionalities to be available. When it comes to Redfish, there is lots of inconsistencies when it comes to implementations across the vendors. So how can that be improved? When we look at these inconsistent implementations, specifications are mostly optional. So, if you want to have a particular functionality within a Redfish version, here's how you do it, but it isn't actually required. There is specifications, resources and collections that do mature over time, but being on a specific version of Redfish does not mean you gain all the resources and functionality with that version. That led to a lot of frustrations with our team as we were going through and developing our automation to configure the BMCs. When we think about, the overall Redfish URIs, building and confirming those URIs to verify a particular URI exists does lead to a lot of chattiness from a protocol perspective. When we think about, that doing those types of configurations at the edge, that does get very expensive, and it can lead to potentially higher failure rates, if there's a quick blip in the network, things like that. The guaranteed URIs that come with Redfish version 1.6 does help, along with the expand feature, can save some repeated calls if it is actually provided with that particular URI.
Awesome. Excuse me. So as we look to, kind of review and wrap up here, these are some of the call to actions that we'd like to see and be a part of. So first and foremost, Target is the very first large retailer to join the open compute community in the presence we have. But we're looking to partner with people all over the board. It doesn't have to be just retail. Ultimately, we give back what we learn. Others can take advantage of that, and then also provide feedback, and we can adjust as needed. So how do we get going there? Let's get more people in the community that are possibly looking at or working on products that could be considered OCP. Let's work on getting those products inspired or accepted by that community. Another thing is 19-inch rack solutions. Obviously, we have a lot of racks out there. We talk about all of our edge locations, our data centers, and it's built on traditional 19-inch racks. There's a few solutions out there. I think the eagerness to come up with more is increasing. A lot of rumblings, and you hear things in the back about more 19-inch solutions. So that's one thing we're interested in, digging into also. Another one is the presence of a 1U node. We've learned with the 2U, 3 node solutions that there's limitations. There could be wattage limitations, memory limitations, storage, all that. We start looking at the 1Us, we can flex out a little bit more while there's more landscape. The reduced efficiency is not there. We still get that increased efficiency, power, cooling, but we get flexibility. So the 1U node is an interest of Target. In addition to that, the ability to offer AC and DC power in that same node. So we can now deploy this from distribution or our data centers all the way to the edge.
So when we think about Redfish, right, Target would really like to see a true consensus on Redfish and really see it as treated as like a first-class citizen, right? It's going to help keep our automation as zero touch as possible and keep it intact. Current versioning requirements of, something as N-2 or at least N-2 would be really helpful. From an open BMC perspective, we're starting to, learn about things here and really kind of get through leveraging that for standard automation across all compute. And we're looking to hear from others who have utilized open BMC and what their experience has been. When we think about firmware, just overall basic functionality is something that we would like to hopefully see adopted across all BMCs. Standard authentication services, such as AD, LDAP, OAuth, availability, right? Minimal restarts, minimal resets as much as possible. We do understand that there are certain configurations that do require resets, but let's reset only when truly needed. And then, standard setting preservation, right? Being able to preserve settings once BMCs have been configured really helps ensure that we can maintain a consistent configuration across all of our BMCs. And last but not least, OpenRMC. This is something we're really starting to just initially take a look at. But again, as just like the open BMCs, we're looking to learn and hear from others who have been utilizing OpenRMCs and what their experience has been. And finally, I'd just like to close with, Target is just getting started on their OCP journey, and we'd love to be able to talk to others and hear from you and what your experiences have been as you've gone through the open BMC or open compute journey.
Thank you.